Hi everyone, and welcome to MathSux. This video is going to help you pass Algebra 2. In this video we're going to go over how to solve for exponents by looking at 3 different examples using the same base and using different bases. Then you can try the practice problems at the end of this video on your own. So what is an exponential equation? An exponential equation is an equation where the exponent is an unknown variable. So here's just like an example of what an exponential equation looks like. Y equals a to the x. So the a represents the base and is always going to be a number, and x is just the exponent, the unknown variable. So this is just the form an exponential equation takes. But sometimes we're going to be asked to solve for this unknown exponent, this unknown variable, and there are 2 methods of doing this. So what happens when we need to solve for the unknown exponent? If we need to solve for the exponent, and we're given an example like this, where they have the same base, notice a to the x is equal to a to the y, so they have the same base, they both have a base of a. We can actually just set the exponents equal to each other and solve. So we would just say, in this case, we would just say x equals y. The next method, if they don't have the same base, so if they have different bases, so here we have b to the x is equal to a. So notice we have a base of b here and a base of a over here. So whenever there's different bases like that, you can't just set them equal to each other. You can't just set the exponents equal to each other. What you're going to need to do is take the log of both sides and solve. So here on the side we did log of b to the x is equal to log of a, and we would solve using log. So now let's look at our first example. We have 5 to the 4x equals 5 raised to the 2 times x plus 2. So notice here we want to ask ourselves, do we have the same base? And yeah, these are both 5s, right? So we know that these are the same base. And because they're the same base, we can take the exponent values of each and set them equal to each other. So we can bring down 4x and set it equal to 2 times x plus 2. And all we need to do is solve for x like we would any other normal algebra problem. So let's just do that. So we have 4x is equal to 2. So notice this needs to be distributed. So we're just going to do 2x plus 4 and subtract 2x from both sides. And we get 2x is equal to 4. Divide by 2 on both sides and we get x equals 2. And that's our answer. And on the side, if you want to check it, you'll see that it works out. So if we do 5, now 4 to the 2. So you can see that this checks out perfectly. For example number 2, so let's look at this second example here. We have 5 to the x plus 9 is equal to 25 raised to the 2x. So we need to ask ourselves, do we have the same bases here? We have a 5 and a 25. So they are not the same bases, but notice that 25 can actually be rewritten as 5 squared, right? So 25 is equal to 5 squared. So because of that, we can actually rewrite this part of the equation here. So we can say that this is equal to 5 squared. But we want to bring down this exponent that's already here. So we have 5 squared for 25, but then it's already attached to a 2x. So we're just going to bring that down over here. And on the left-hand side, we're just keeping that the same. So we have 5 to the x plus 9. And now we have the same bases, right? We have a 5 and a 5, so now they're the same base. Which means we can take the exponent values and set them equal to each other and solve for x. So let's do that. So we have x plus 9 is equal to 2 times 2x. So we get an answer of x equals 3, and then we could just check on the side here. So we have 5, and then we're just going to plug in a 3 for x. And we see that we are right, and we got our answer. Now for example number 3. So notice these are not matching. So since they're not matching, and we have to ask ourselves, can we change these bases so that they can match 3 and 4? No, unfortunately no. So what we're gonna have to do here is use logs. So to do that, we're just going to log both sides. So we're going to do log of 3 to the x and set it equal to log of 4. So notice here we have log of 3 raised to the x. So just a little reminder about the power rule of logs. So logs have these different rules. So the power rule tells us that we can take this exponent and bring it to the outside. So we get x log of 3 is equal to log of 4. So we're almost done here. All we need to do is get x alone. So notice, to do that, we're just going to divide log of 3 on both sides. This cancels out, and we get x equals log of 4 over log of 3. And that's our answer. You could also plug this into your calculator. So we have log of 4 divided by log of 3, and you could see that we get this number 1.261859507. And again, you can check this as well in your calculator by plugging in. You can either plug in this number or plug in log of 4 over log of 3 into your calculator and see what we get. So we have 3 raised to the power and we get 4. So you know our answer is right. So if you're looking for more, check out the practice questions right here. The answers are up on the blog MathSux.org. The link is in the description below. And if this video helped you, please give it a like and subscribe. Thanks so much for stopping by, and happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!